So this is 2.5 exponent laws, and it's the second part, and we're going to learn the last three laws of exponents. So before we can start, or before we can actually do the math lab, we have to I just have to kind of review how to write these types of powers as repeated multiplication. So in this case, this whole thing is the base to that power. So since it is 5 to the power of 2 to the power of 3, I have to write 5 to the power of 2 3 times. Okay, since this whole thing is the base to that power, this tells me how many times I write this base, so I write it 3 times. So now this can be written as 5 to the power, or 5 times 5. This can be written as 5 times 5. And this can be written as 5 times 5. Okay, so we're going to use that knowledge in our first math lab. In the second math lab, we'll have to know how to expand these types of situations. So here, this is the base, that whole thing is the base to that power. So I write it the base twice. So 3 times 7, and again, powers are repeated multiplication, so I repeat the multiplication twice. Okay? Now another thing we have to know is that the commutative property of multiplication means that order in multiplication doesn't matter. So I can rearrange this in this order. Okay, so that's going to be really helpful for the second lab that we do. So let's go take a look at the first lab. Okay, and I'm going to turn it into typing just to make it a little bit easier. So here, 2 to the power of 2 is the base to this exponent of 2. So I write it twice. And then I can write each of these powers, because this is 2 to the power of 2, so I can write it again. And this is 2 to the power of 2, so I can write it again. So now what we can do is when we have this all expanded, I have 1, 2, 3, 4. So this is actually 2 to the power of 4. So I would press pause right now and see if you can fill out the chart. And when you're ready, come back, press play, and see if you have what I have. Okay, so welcome back. So the next one is 3 to the power of 3 times 3 to the power of 3 times 3 to the power of 3. So I have 3 times 3 times 3 for the first one, and I'm just going to separate it into my 3 groups. Okay, so I just separated it just for convenience sake. It's still all multiplication. I have 9 of them, so it's 3 to the power of 9. Okay, so in this case I have -4. Oh, this is going to be really, I might have to, let me just erase this. I have to use it because exponents are so hard to do with typing. So this will be -4 to the power of 2. I'll just type this out or write it out. Times -4 to the power of 2 times -4 to the power of 2 times -4 to the power of 2. Okay? Because this whole thing is the base to that power. So now again, if I want to write it or type it out, it'll be -4 times -4. That'll be the first set of 2 times -4 times -4. That's the second set of the second power. So -4. And again, we always have to remember the brackets. -4. That's the third set. And here is the fourth set. Whoops, I forgot the multiplication sign. Okay, so I'm just going to move this over so I can write my other answer. So I have 1, 2, 3, 4, 5, 6, 7, 8. So another way of writing this would be -4 to the power of 8. we'll take a look and see what did I actually do with the numbers here. Like how could I go from here to here with missing out, like, you know, with skipping all those other steps. Okay, well, now that you've had a time to look at this, if I go 2 times 2, I'm going to get 4. If I go 3 times 3, I'm going to get 9. And if I go 2 times 4, you're going to get 8. So really, all I'm doing is multiplying these two powers together. I should get 5 to the 12. And that is actually the pattern. And most students get that. So this is what, I'm just going to move this over a little bit so you can see it all. So this is called power of a power. So I am exponing, I have an exponent, like a power is my base to a bigger power. I call it double power. So what this says here is that I have a power here, and this thing is the base to that exponent. So it's kind of a power within a power. So if I ever see that, one base, two exponents, I'm just going to erase that, one base, two exponents, all I have to do is multiply these two together. Okay? So I multiply the two exponents together and my base can't equal to 0. Okay, so that's a can't equal to 0, so my base can't equal to 0. And the m and the n, so your two exponents can only be whole numbers. And whole numbers are 0, 1, 2, 3, 4, 5, and up. So they have to be positive numbers, and it can also be 0. In Math 10 Common, you're going to be dealing with negative numbers or negative integers, and I'm not sure which level you do, but you will also be dealing with fractional exponents as well. But just for grade 9, you're only going to be dealing with exponents that are 0 and up, and they're all going to be whole numbers. So let's take a look at this. So I have a base of -7, which is to an exponent. That's my first power. And then this power is the base to another exponent. So it's a power within a power, or double power. So all I do is I multiply the exponents. Now I can write that all out, and I can show you if I do all that repeated multiplication again, it will actually equal to -7 to the power of 6. Same thing, here's a base to one exponent, so here's a power, and that's the base to another exponent, so it's a power within a power, or double power as I call it, so 2 to the power of 4. So here's a quick check, so just pause your video, you try it first, and then press play and see if your answers match mine. So again, I have a base to my exponents, two exponents, so I multiply them. And I have a base of -6 to two exponents, so I multiply them. And that's about it. Okay, I'm going to stop the video here, and I'm going to, just so that they don't get too long, and this will be part 2 of my next video.